Alright, our focus of this lesson today is I can classify and visualize word problems. Visualizing we do often in reading, and that's really important in math so that you know what is going on in the problem. Sometimes it takes 1, 2, 3 times reading the problem to really get a good idea of what's going on. So practice reading your problems multiple times and visualizing what the story is telling you today. The classifying part, we often use our tree maps to classify things into different categories. I'll show you an example right now. So here's my word problems tree map. Notice that there are 3 different branches, so I'm going to have 3 different categories that we're talking about today. Here are the 3 different categories that I can classify into. Change situations, so if something is changing, so imagine I have something to start with and I add something to it, that would be a change situation. A collection situation. And for collection situations, we often use math mountains or break-apart drawings. So you will see these today used in collection situations. And this often has to do with having 2 different groups of something. So I have 9 cats and 4 dogs, so 2 different groups, and I collect them together. So I say, how many animals are there altogether? And my answer would be 13. That would be a collection situation. And comparison situations, where I have some amount of something and an amount of something else. So we could say I have 9 dogs and 4 cats, and how many more dogs do I have than cats? In this case, I would have 5 more dogs than cats. So I use comparison bars to represent and visualize comparison situations. And you'll notice I didn't write anything under change situations. Oftentimes we will just write an equation. So 9 plus 4 equals 13. The first type of situation word problems we're going to look at today are change situations. So situations in word problems. Change situations can be change plus situations or change minus situations. Over here we have change plus, and here we have change minus. So these ones will be showing something getting bigger, and this will be showing something getting smaller. Notice that I've changed the numbers for these problems because I want you to show an example on your paper using the numbers represented there. Your equation is different than mine. You can stop after each problem that I demonstrate and then do yours with your numbers. So this whole time I want to be practicing visualizing the word problems as I go. All right. Unknown result. So result is an answer. So that I'm going to end up with an equation here where I don't know the answer. Dan had 7 cherries. Then he picked 8 more. How many does he have now? As I'm visualizing this, I'm visualizing Dan holding 7 cherries. Then I see him picking 8 more. So my equation would say this. He had 7 cherries, then he picked 8 more, and I don't know how many cherries he has now. I'm going to use the variable c to show that. Remember, variables represent unknown numbers, and my unknown here was the result, or the answer. Next, Dan had 7 cherries, then he picked some more. I'm visualizing Dan having 7 cherries, then he's picking some more, but I don't know how many. Now he has 15 cherries. So he ends up with 15 cherries is what I'm visualizing. How many did he pick? All right, well, in my mind I saw this. He had 7 cherries, then he picked some more cherries, we'll give it the variable c, and he ended up with 15. So here, the unknown change, that was what I was demonstrating here, is how much bigger did it get by? And I wrote this equation to show that. Notice that I'm using the same variable. It doesn't matter. I'm just using c because we're talking about cherries. I could use any variable. I could use x, y, z, whatever I want. But it made the most sense for me. All right, unknown start. So I don't know how many I start with this time. That's what it's telling me. Dan had some cherries. Okay, so I don't know how many he started with. Then he picked 8 more. Okay, so he picked 8 more. I'm visualizing that in my head. Now he has 15 cherries. How many did he start with? So I don't know how many he started with. So C would be how many did he start with. Then he added 8 more to his collection, and he ended up with 15. So I have 3 different equations here for 3 different problems, even though they all have to do with the same number. I had unknown result, unknown change, and unknown start. All of those had me visualizing that Dan was adding more cherries. So all of these are unknown change plus, change plus. All right, we're going to switch over to change minus now. Again, I've switched the numbers so that you can practice on your own with your own equations. Just so you know ahead of time, I am going to be using the same variable C to represent cherries, the unknown number. All right, unknown result. So I'm guessing that my answer is going to be unknown. So Dan had 15 cherries. Visualize that. He's got 15 cherries in his hand. Then he ate 7. Okay, visualize him eating 7 cherries. How many does he have now? Okay, so I visualized him having 15 cherries. Then he ate 7. That means 7 go away. How many cherries does he have now? The unknown is the result, the answer, or the difference in that problem. Remember, you can pause after each problem. I'm going kind of quickly. Dan had 15 cherries. All right, again, I'm seeing him start with 15 cherries. Then he ate some of them. I don't know how many he ate. I'm visualizing him eating some cherries, but I don't have a number in my head. Now he has 8 cherries. How many did he eat? Okay, well, I know that the answer is 8 because that's how many they said he ended with. He started with 15, and he ate some. So some went away. Some are now in his belly. So there's my equation. My unknown, there is the change. How much did it change by? And unknown start. I wonder where I'm going to put my variable this time. Probably at the start. Dan had some cherries. Okay, so I visualize him holding cherries, but I don't have a number in my head because it doesn't tell me. Then he ate 7 of them. All right, he had some, he ate 7. Now he has 8 cherries. So I'm visualizing after he ate the 7, he still got 8 left. How many did he start with? All right, so he started with some cherries. He ate 7 of them, so 7 of them are known as belly, and there are 8 left over. How many did he start with? So this is the equation that represents an unknown start. On the bottom, it's going to ask you to write a word problem choosing your problem type. So I want you to write your problem type on the line. So it could be change minus, unknown, start, just like the one we just did. It could be something else. All right, now we're moving on to collection situations. Collection situations can have an unknown total or an unknown partner. If you look at the break apart drawing here, remember the top is the total and the bottom 2 are the partners. Partner, partner. All right, let's read our directions. Make a break apart drawing and write a situation equation. Use a variable for the unknown. So for each one, I'm going to see 2 different answers. One is the break apart drawing and one is the equation. The break apart drawing is already made for me, but I just have to move around the variable based on what the problem tells me. So let's visualize. Put together, unknown total. Anna put 7 dimes and 8 nickels in her pocket. Visualize that. How many coins did she put in her pocket? So my break apart drawing, it's got 3 parts. She had 7 dimes, 8 nickels, and she put all those into her pockets for a total number of coins. C coins. Now the difference between a collection situation and the change situation that we did last is these coins were always there. We're just now putting them together. Whereas before, we actually changed how many cherries there were. This is not changing anything. We're just seeing that, oh, we had 7 dimes and she had 8 nickels. How many does she have altogether? So this equation would look like this. I've got 7 dimes plus 8 nickels, and I get a total number of coins, C. Next, take apart. Take apart is another word for, or another phrase for subtraction. So Anna put 7 coins in her purse and 8 coins in her bank. How many coins did she have in the beginning? So again, I'm visualizing this. She had 7 coins. Those go into her purse. She had 8 coins into her bank. And how many coins did she have to begin with? Well, guess what? My equation is actually going to look the same. I'm just visualizing this differently. She didn't actually put them together. She is putting them in different spots. And I want to know how many does she have total at the beginning? C, coins. So she had 7 in her purse, 8 in her bank, and her total number of coins would be there. Okay, now this time they're just going to tell me what she has. She has 7 dimes, and she has 8 nickels. How many coins does she have in all? So nothing has moved. They're all still there. They just want to know how many does she have in all. So she had 7 dimes and 8 nickels. How many does she have in all? C. All right, moving on to unknown partner. So remember our math mountain or our break apart drawing, the total goes on the top, T for total, and the partners are down here. So this time, one of these is going to be missing, the partners. Let's see here. Anna, visualize. Anna put 15 coins in her pocket. 7 are dimes and the rest are nickels. How many nickels are in her pocket? So here I'm visualizing she has a total number of coins, 15. So that goes to the top of my break apart drawing. And she has 7 of them are dimes. And how many nickels does she have? That's my other partner. So I would say she has a total of 7 dimes plus a total of, I don't know how many nickels. How many coins is that in all? That is 15 coins. This would help me solve for n nickels. All right, take apart. Anna had 15 coins. Visualize that. She had that at the beginning. She had 7 dimes, and the rest were nickels. She put all 9, oopsie, forgot to erase that one. This should be 7, same as before. She put all 7 dimes in her purse and all the nickels in her bank. How many nickels did she put in her bank? There's a lot of information there, but really it's the same situation. They're saying there are a total of 15 coins, 7 of them are dimes, and the rest of them are nickels. So again, I'm getting the same, using the wrong numbers again. 7 dimes plus n nickels is going to give me a total of 15 coins. And I would solve for n. Lastly, Anna has 15 coins. She has 7 dimes and the rest are nickels. How many are nickels? I'll let you figure that one out yourself. All right, on this page we are talking about additive, so adding comparison situations. And they ask how many more or how many fewer. They can have an unknown quantity or an unknown difference. Make a break apart drawing. We're not going to make a break apart drawing. We're going to do a comparison situation. We're going to do comparison bars. And write an equation for each situation. Let's look at the first problem. Unknown difference. It's going to ask me how many more. Allie has 15 balloons. Lisa has 20 balloons. How many more balloons does Lisa have than Allie? All right, it asks how many more balloons. So I would make a comparison bar. They are comparing these two people, Lisa and Allie, and I know that Lisa has 20 balloons and Allie has 15, so I made Allie's bar smaller. And notice that I'm trying to keep these the same total length, Lisa's total length and Allie's total length. And I am missing how many more. So I'm going to write a B there for balloons. How many more balloons does she have? So Lisa has 20, and Allie has 15, and whatever the difference is B, the number of balloons. It's a subtraction problem. 20 minus 15 equals B. How many more balloons she has? I'm going to let you do the next ones by yourself, but I am going to skip all the way to number 18 because it is a different type of problem that has misleading language. So it's trying to lead you in the wrong direction. When we see this, it's really important to focus on what the details are. So in this problem, I see that this person's name, this is a boy, it says he, so this must be Ali, not Allie, like I said before. So Ali has 15 balloons. Visualize that. So he is Ali, he has 5 fewer than Lisa. How many balloons does Lisa have? So this is confusing because it sounds like Lisa might have 5 fewer, but that's not true. It says that Ali has 15 balloons. So this is Ali's comparison bar. And Ali has 5 fewer. So we really need to do a good job of visualizing this. It says Ali has 5 fewer, which means that Lisa has 5 more. So I'm going to make a space here for 5 because it says that Lisa's comparison bar needs to be 5 more. So what would I have to do? What equation would I write? Well, I see that Ali has 15 plus 5 is going to equal a total of the number of balloons Lisa has. So I would write 15 plus 5 equals the total number of balloons B that she has.